Yeah, you are.
Okay. So, what we're going to start discussing today is going to be the basis for the formation of ionic compounds. So we've been talking about the elements. Elements combine to form compounds. Now, compounds consist of elements that combine in a very specific ratio. The ratio is important. For example, carbon can combine with oxygen in a 1-to-1 ratio, and it can combine with oxygen in a 1-to-2 ratio. This first one you might have heard of. It's called carbon monoxide. And it will kill you by replacing the oxygen in your blood. The second one you probably have heard of. It is carbon dioxide. Which is a gas in the atmosphere that keeps heat on the earth. Another one of them, another example is H2O compared to H2O2. One of these you are told to drink every day, and that is water. But the other one is harmful if you drink it. However, it's great for cleaning out wounds. It's hydrogen peroxide. what I'm trying to illustrate, folks, is that the ratio matters. You alter the ratio, you alter the identity, you alter the behavior of the compound. So again, compounds have formulas where the elements have combined in a very specific ratio. That ratio can be used to identify compounds. And so today we start our conversation about compounds, which is going to be on the next exam. Now, there are two types of compounds that we will discuss in this class. The first type of compound we are going to discuss is going to be an ionic compound. An ionic compound contains an ionic bond which is an electrostatic attraction between a cation, which is a positively charged ion, and an anion, which is a negatively charged ion. The second type of compound that we're going to talk about is considered to be an inorganic. Well, really, there's three. Covalent compound. A covalent compound contains a covalent bond which arises through the sharing of electrons. Between two atoms. The third type of compound we will talk about is a kind of a mix of the two. It is going to be an acid, which I'll discuss acids in more detail when we get there. You're going to find that when we start naming compounds, you have to be prepared to recognize whether a compound is ionic or whether it is covalent, because depending upon whether the compound is ionic or covalent will determine how you have to name it. The key is an ionic compound will contain a metal. Whereas a covalent compound will contain nonmetals and metalloids only. For your test on Friday, that is one of the sets of definitions you had to be prepared to recognize, is whether you're working with a metal, non-metal, or metalloid. So I'm going to go over the metalloids again, because they separate the metals from the non-metals. The metalloids are boron, element 5, silicon, element 14, germanium, element 32, arsenic, element 33, antimony, element 51, tellurium, element 52, and astatine, element 53. I'm sorry, astatine, element 85. If it is to the right of what I just labeled, it's a nonmetal. If it is to the left of what I just labeled, it is a metal. And again, if it's a metal, it's an ionic compound. If it contains a metal, it's an ionic compound. Now what we're going to do is we're going to talk about the development of cations and anions. Cations result from the loss of electrons to make a positive charge. That means that cations have fewer electrons than protons. Anions result from the gain of electrons. To make a negative charge. meaning anions have more electrons than protons. The E negative, by the way, is a common way to denote an electron. I don't remember if I've used that yet. Your metals will form cations. Your non-metals will form anions. Okay. So let's take a look at sodium. Sodium is number 11 on the periodic table. So its atomic number is 11. And therefore, the number of protons equals 11. And the number of electrons equals 11 in sodium. The other thing that I note is that sodium is a metal because it is to the left of the metalloids. So sodium, with its 11 protons and 11 electrons, is going to lose one electron to make sodium plus cation. So if it loses one electron, therefore it's going to have 11 protons still and 10 electrons. Notice the protons did not change. Protons can never change. Protons determine the identity of the element. If I change the protons, I change what element I'm working with. So sodium had 11 protons, no matter what form it is in. The only thing that can change is its electrons. Remember, it's the electrons that are responsible for the element's reactivity. So the only thing that can change is the electrons. Now, looking at what I have here, you'll notice I placed a charge. Let's look at where that charge came from. What charge does a proton have? plus 1. That makes that plus 11 because there are 11 protons. What charge does an electron have? A -1. That makes that a -11. So when you add those two together, they come out with 0. Now let's do that for the cation. It has protons. Protons you said are a plus 1. It has 11 of them, so that's a plus 11. But sodium, being a metal, loses electrons. It has 10 electrons, which is a -1, so that's a -10. When you add that together, that's a plus 1. It is from this information that positive on the sodium is generated. Now, you may ask, how I knew sodium had a plus 1 charge. The complete answer is not going to be revealed in this course because you have to learn electron configurations, which is something you'll learn in your next course in line. But this sheet that you picked up, the last one you picked up, provides some information for you. Look at all of the elements in group 1. Look at all of your alkali metals. What charge do they have? A plus. Your alkali metals will always form a plus 1. I don't care who they pair up with when they make a compound. If it is a group 1 metal, it will always have a plus 1 charge. If it is an alkali metal, it will always have a plus 1 charge. Look at your group 2 alkaline earth metals. What do you notice? Plus 2. Alkaline earth metals, no matter what they combine with, is going to have a plus 2 charge. Look at silver. Silver is a plus 1. No matter what silver combines with, it carries a plus 1 charge. Zinc and cadmium are both plus 2. No matter what zinc combines with or what cadmium combines with, it will always have a plus 2 charge. And then aluminum and gallium and indium, they always carry with them a plus 3 charge. These you are expected to know. The reason you are expected to know these in particular is because, again, no matter what they combine with, they will have that charge that's indicated on this periodic table. Now, to help you memorize it, because I just said you have to know it. Group 1, plus 1. Group 2, plus 2. Now, for the other, it's easier to see on this thing I've drawn. You look at it, they form a nice set of stair steps. To figure out the charge, look at how many elements are in the stair step. In the case of silver, it's the only element in that step. That's why it's a plus, so it's +1. Look at zinc and cadmium. There are 2 elements in that rise. They're both a +2. And aluminum, gallium, and indium, there are 3 elements in that rise. They're all +3. That's how you can help yourself memorize these particular ones. So let's look at another element. Let's look at aluminum. Aluminum is element 13 on the periodic table. Therefore, its atomic number is 13. Therefore, its number of protons equals 13. And the number of electrons in a neutral atom is equal to 13. Aluminum is a metal, so it forms a cation. If we think about aluminum and what we just said, if it is element number 13, it has 13 protons, which are all a +1, so that's a +13. It has 13 electrons, which are all -1, so that's a -13. So that's why we say if it has 13 protons and 13 electrons, it's a neutral atom because it has no charge. Now we know aluminum forms a cation, so it has to lose electrons. What charge does it make? What? It makes a positive because it's cation. But specifically, what charge does aluminum make? Huh? It makes a +3. Though when we talk about charges, oftentimes we put the number first. So it's a 3+. How many protons will it have? 13. Why? It determines the identity. You cannot change the number of protons ever. So it has to still have 13 protons, meaning it is a +13. Now, the number of electrons, which are a -1. How many electrons does it have? That is correct. It has 10 electrons because that would make it a -10, which would add up to a +3. Now, why do I do this math with you? Because it is common, though error, a common error is for somebody to tell me there's 13 protons and 16 electrons. But if you do the math, that's a +13, a -16, which comes out to be a -3. That is incorrect because it doesn't come out with the charge of aluminum. So that's why I do the math with you, is so that you have a way to check yourself to see if you're doing it correctly. Now, I only gave you 16 of the metals. What about all of the rest of these metals? Unlike group 1, group 2, silver, cadmium, zinc, aluminum, gallium, and indium, the rest of the metals can have more than one charge. I'm going to have to specify for now what that charge is. For example, iron can have a 2+ charge, or iron can have a 3+ charge. I know it can have multiple charges because I did not list it. I only listed the ones that are always the same. If it's not listed, that means it can have multiple charges. Iron is element number 26. So it has 26 protons, no matter what, all carrying with them a +1 charge. How about the number of electrons? Cations result from the loss of electrons, meaning they have fewer electrons than protons. So yes, there are 24 electrons in iron 2, and you can check yourself by realizing that that adds up to a -24, and therefore the two together, the protons and electrons, add up to a +2. And the iron 3+ has 23 protons, and therefore, not protons, electrons. And therefore it's a -1 charge, so it adds up to a -23. The two together, the protons and the electrons, add up to a +3 charge. Questions? I'm not going to talk about how to name them today. I'm just trying to get these concepts of what is a cation, what is an anion, and what does that mean down today. Speaking of that, let's talk about anions. There are going to be two types of anions you're going to encounter. They are going to be the elemental anions. Which are anions of elements. And they are going to be the polyatomic anions. Which poly stands for many. Atomic, atom. Ions. We're only going to discuss one of these today, and that is going to be the elemental anions. We're going to build up to everything. Before test 3, you are going to have all of them. The elemental, anions as well as the polyatomic anions memorized. Looking back at this periodic table, the anions are nonmetals and a couple of metalloids. What do you notice about all of the anions in group 15? They're a negative charge, but more specifically, they're a -3 charge. What do you notice about all of the anions in group 16? They're a -2 charge. And what about all the anions in group 17? -1. Folks, if it is an anion of an element, these will be their charges. They don't change. If it is an anion of oxygen, it will always be a -2. If it is an anion of chlorine, it will always be a -1. If it is an anion of phosphorus, it will always be a -3. In other words, this particular periodic table, I gave you the ones that are always the same. Gave you the things that are always constant. Now, let's look at our anions. Well, let's go ahead and look at chlorine. Chlorine is atomic number 17. So it has 17 protons, and in a neutral atom of chlorine, it will have 17 electrons. So in our neutral atom of chlorine, 17 protons and 17 electrons. Protons carry a +1 charge for a +17. Electrons carry a -1 charge for a -17. That is why it's called neutral. Now, chlorine is a non-metal or metalloid. Your non-metals and metalloids form anions. So chlorine is going to form an anion, which means that it's going to gain electrons. Chlorine, when it is an anion, is in group 17, so its charge is -1. So we have 17 protons. At a +1. And if it gains electrons, that means we're going to have more electrons. We're going to have 18 electrons at a -1. You can prove that you went in the correct direction because a +17 and a -18, when added together, is a -1 charge. Let's look at phosphorus. Phosphorus is atomic number 15. meaning it has 15 protons and 15 electrons in a neutral atom of an element. So P by itself has 15 protons at a +1 for a +15, and 15 electrons at a -1 for a -15 to give you a neutral atom. Phosphorus is a non-metal. Non-metals gain electrons to form anions. Phosphorus is in group 15. What charge does a group 15 non-metal have? -3. So it makes P3-, meaning it has 15 protons because that can never change. And it has how many electrons? 18. And you can check yourself because it should add up to a -3. Now, folks, I've used some of your terminology, and I hope you realized it, that you needed for the exam this coming Friday. Some of that terminology includes atomic number. How I determined the atomic number was I looked at the periodic table to figure out what number the element was. The atomic number in a neutral atom of an element, which is all you're going to be tested over, is neutral atoms of elements. The atomic number is equal to the number of protons, which is equal to the number of electrons. I use the terms metals and nonmetals and metalloids because you have to know that distinction in order to know whether it forms a cation or whether it forms an anion. Now, you don't have to know that for the test. You just have to know whether it's a metal, a metalloid, or a non-metal for the test. I use the term group. A group is a column. I use the term period, which is a row. I use the term alkali metals, which specifically focuses on group 1 metals. Does hydrogen count as an alkaline metal? No. Be careful. I've seen people get excited and make hydrogen an alkali metal. Is hydrogen a metal? No. I've seen people get excited and make hydrogen a metal. I use the term alkaline earth metals, which is group 2. A term I did not use, though I should have, is when I talked about group 17. What are they? The halogens. And group 18? Noble gases. I was trying to use your terminology today to help you remember some of it, since it's going to be on the test Friday. Any questions for me about today or the test Friday? Yes. What we went over today is not on the exam. That is starting exam 3's material. Other questions? Okay, note on the board. Bring your calculator tomorrow. Friday. If you don't have a calculator, you cannot do the mathematics. Cell phones, tablets, I should not see anything on your desk but your calculator, pen or pencil. You can have your drink on your desk. But those are the only two, and you can have highlighters. Highlighters are great for this exam because when you get to the periodic table, sometimes I ask you to shade in certain pieces of information. And you can use a highlighter to shade if you want. Any questions? If you need to visit with me before the exam, I will be in my office from 8 until noon, the day of the exam, or 8 until 11, excuse me. I've got another exam at 11. 8 until 10:50 technically. So I will be there if you have questions. If you can't meet during those times and need to meet tomorrow, you're gonna have to email me to find out when I'm in my office because I don't even know my schedule. It's a day-to-day thing for me. Okay, I will see you Friday. The only conversions on the test is you have to be able to use density as a conversion factor. So there's no other conversion. It should record it on it. Yeah, yeah, I think I posted 10. 7. I'm pretty sure I posted 7.
Question about the rounded. So do you have to know each individual one, like don't ask you, what is a rounded? Or is it just gonna have?
You have to know who the metalloids are.
So like
Boron, silicon, germanium, arsenic, antimony, tellurium has to be. You don't have to write the names. You do have to be prepared to know the
I know
symbols.
where they are.
That's what happens. You're gonna have your regular periodic table. And if I ask you, I think on that one, I asked you to write the symbols. So you would write B, SI, GE, AS. You would write the symbols into the appropriate location on the periodic.
We have to do that for the, how long gives the normal classes to?
I'm not gonna answer whether you have to do that for all of them, or you're just gonna have to read which ones require you to put the element symbols in, and which ones require you to just shade.
And we will have a periodic table.
You will have a periodic table, yes.
So we don't have to like remove the symbol.
You have to know where they are on the periodic table. But do you have to be able to rattle them off to you like I just rattled them off to you? No. You're gonna have a periodic table.
I have another question. Carbon not have a charge?
Carbon does not have a charge. It is, now, when it combines with oxygen to make a polyatomic ion, it does. But carbon by itself does not have a charge because it requires too much energy. That's something else I don't get to in this class. if you have to make something, besides the transition metals, which are pretty big atoms, the small atoms though won't do this. They won't make anything above a 3. Because anything above a 3, it requires too much energy. And carbon would have to make a +4 or a -4, so we can't do it. Because it's a small atom and it's it would be trying to make something that had 2 hydrogens.
None of this is gonna be on the test. Right?
None of today and none of this. This is for the next couple of weeks as we go through material.
Thank you.
Just look this over and see if I have everything on there.
These are main group, transition, lanthanides, actinides, good. Halogens, metal gases, alkaline earth, alkaline, it's just alkali, not
Oh,
just alkali.
is hydrogen?
The ones that you highlighted are correct for the yellow.
Hydrogen.
Hydrogen is a non-metal. The ones that you highlighted that are in red are good. The ones in pencil are all metal. It looks good from what I can see.
So. Thank you.
Have a good day.